So this one, any number that can be written as a fraction is called a rational number. We went over this before. It's rational if it can be written as a fraction. Every rational number can either be written as a terminating decimal or a repeating decimal. What does the word repeating mean? Pretty easy. What does the word repeating mean? Angelo? Yeah, it keeps going, right? It happens more than once. It keeps going. What about terminating decimal? What does terminating mean? What does terminating mean? Sophia? It stops, to end. Like if you terminate something, you end it. Everybody look up. Let's match these terms. Terminating decimal. Which one of these two on the side matches terminating decimal? Dominic. Which one? The bottom one, yes. So, terminating decimal means the decimal form of a rational number which has a repeating decimal of 0. What that means is it keeps going 0, 0, 0, 0. But do zeros matter? No, they don't matter. So, all that matters is it ends 6.2 or 0.625. That's it. So, as such, the repeating decimal is the top one, the decimal form of a rational number. But it keeps going. Look at that 3. Does that 3 ever stop?
No.
It's repeating forever. It keeps going. It's repeating forever. So, I want you to write each of these fractions as a decimal. Each of these fractions as a decimal. So, one way we can do it is we can use long division. So, for 1/2, which of the numbers goes inside the house? Which goes inside the house, Shiley? 2? Who agrees? Which goes inside the house, Dominic?
This is what Miss Kirkpatrick taught me. In and out, so the one will go in and the 2 will go out.
Yes, in and then out. 1 is being divided by 2. So the one on the top, 1 and 2. Can 2 go into 1? No, so we put a 0. Then as we know before we did this, we have our decimal, right? We do, matches. How many times does 2 go into 10, Dominic?
5 times.
5 times. We get exactly 10, which means we get 0 here. Do we need to continue?
No.
So is this a terminating decimal or a repeating decimal? What do we think? Terminating or repeating? Justin? Terminating, because it ends. We don't go any further. It's always going to just be 0, 0, 0. It doesn't matter. So 1/2 as a decimal is 0.5. I want you to try the rest. 3/10 and 4/5. So the second one, 3/10. As we know, this is in, this is out. So it's 3/10. How? So 10 goes into 3 how many times? 0. So as we know, we decimal. By the way, if our top is smaller than our bottom, it's always going to start with a 0. If our top is smaller than our bottom, it's always going to start with a 0. If our bottom is bigger than our top, then we will have it be some kind of number. Excellent. So we put our 0 here, right? It goes into it 3 times, which is 30. Hey, look, we get a 0. Is this a terminating decimal or a repeating decimal? What do we think? Raising our hands. Justin? Terminating. Excellent. We get 0.3. Let's look at this last one. So it is 4/5. 4 goes inside, 5 goes outside. 5 goes into 4 how many times?
0.
So we put a dot. We put our decimal. Then we have a 0. 5 goes into 40 how many times?
8.
It's exactly 40. So it is a terminating decimal. Terminating decimal. Now, I want you to try this one. Write 5/6 as a decimal. Write 5/6 as a decimal. 5/6. Stephanie, which one goes inside the house? The 5, the top number. The top number, so 6. How many times does 6 go into 5? 0. Now, we put this. How many times does 6 go into 50? Ani? 8 times. And what is that?
48.
We raise our hands. Caesar.
Wait, no, I don't know.
What is it? We raise our hands. Dominic?
48.
48. Excellent. What is 50 minus 48, Shiley? 50 minus 48. Kyle. 2. 2. So then we bring down our next 0. 20. How many times does 6 go into 20, Ani? 3 times. That's 18. We subtract. What do we get? 2. We bring down our 0. Hey, look at that. That's another 20. We have a 20 here. We have a 20 here. How many times did it go into 20 before? How many times did it? 3. And guess what? It's going to keep repeating. We're going to keep getting 3, 3, 3 forever and ever. It's going to keep going. Exactly. So, who knows what I can do in that situation, Chris? We put a line on top of which one? The 8 right here? The first 3. Exactly. And we can just write it. We can just write it as 0.83 with a line on it. Why do we use a line? Why do we use a line, Dominic?
So it doesn't keep on repeating?
Yeah, so we don't have to keep writing it. A line goes on forever, right?
Yeah.
Just like that 3 is going to go on forever. That's how we use it. Why don't I write it over both of those numbers, though? Why don't I write it over both of them, Chris? Because the 8 doesn't repeat. If I wrote it over that, what it'd be saying, it would be 8, 3, 8, 3. And that's not accurate. It's not accurate. So, let's see. Here's what I want you to do. I want you to try the guided practice 1 through 6. And I'm going to give you a hint first. So it's page 382. I'm going to give you a hint first, okay? What happens if we have a negative number, like number 2? Number 2 is negative 1 over 33. What happens if I have a negative number? Can I divide like that? Can I divide like that? Yes. All I know is my answer is just going to be negative. It's going to be the exact same as dividing 1 by 33, but at the end, the answer is just going to be negative. Next, here's the other hint I'm going to give you. At number 3, we have negative 2 and 5/6. I can't divide with a mixed number. What am I going to have to do to it? What am I going to have to do to it, Chris?
Add 12 because...
Yes, we have to turn it into a... What do we turn it into? Improper fraction. And Chris is completely right. How do we turn it into an improper fraction, Chris? Yeah, so we multiply by that, and then we add it to the top. So we get 12 plus 5 is 17. So this becomes 17/6, and it's a negative. Doesn't matter. Our answer is just going to be negative. So if we have a negative, our answer is going to be negative. If we have a mixed number, we must turn it into an improper fraction before we solve. Okay? And last thing is I'm actually going to do one of your homework problems for you. Okay? So I'm going to do one of your homework problems for you. So page 383, I'm going to do number 4 for you to give you a hint. Okay? Page 383, number 4. So we have this problem. Negative 6/7. And we want to make it into a decimal. So let's look at that. Negative 6/7. We want to make it into a decimal, right? So the 6 goes inside, the 7 goes outside, and we know our answer is going to be negative. So that's how we write it. How many times does 7 go into 6?
0.
So we bring our decimal up. How many times does 7 go into 60? How many times does 7 go into 60? Who can tell me? 7 into 60, Dominic. 8 times. And we get 56. So we then subtract. We get 4. We bring down our next 0. I'm just going to keep going and doing it for you. And then I'm going to show you our hint. Okay? I'm going to show you our hint.
Wait, what are you doing?
Solving the problem for us. Don't worry, that's why I'm doing it for us. I'm going to keep going to this, so I'm going to go. Don't worry, there's a reason I'm doing this. So we ended with 30 here, We go in 4 times, that's 28. We do the subtraction, we get 2. We bring down our next 0 here. We bring down our next 0 here. We get 20. 7 goes into 20 2 times, so it's 14. We put our 2 here. Don't worry, I'm going to go back and show you. Then we get 6. We bring down our 0, right? Look at this. We have a 60 here, and now finally, we have a 60 there. Once we get matching numbers like that, that means we have found the repeating decimal. So this one's very long, but it repeats, and that's our answer. So our answer is going to be negative 0.857142, repeating, because we had our 60 there, and we have our 60 there. If we kept going, we'd find out that it would keep repeating. Once you find your matching numbers, once you find a matching number, that's how we know that it's a repeating decimal. Just like our earlier one that we did when we had 5 6. When we did it, as we know, we found out that it was, we had the 2, brings this down, it became 18, it was a 2. Notice here, once again, our matching 20s. That's how we know our 3 goes on forever. Whenever you find your matching numbers, that's how you know that you can end, and that's the repeating. That's how you know you can end, and that's the repeating. Our homework is page 367, 368, and 383, 384.